So the previous video demonstrated how we can collect some footage using the Gig-E cameras. Now we're going to go through how we can automatically digitize that footage to yield some useful information and data. So in the Quintic software, if we head to the main tab and then open video file, find our file on the desktop and open that one up. Now you can play that through to have a look. That's completely up to you, and you can toggle with the speed of that as well. But what we need to do is head to the digitisation tab, and then on the left hand side the digitisation menu. So the first thing we need to do is create a frame template. So the number of points relates to the number of markers that we've used on the participant. So you can see here we've got 3 points, and I'll just label them up accordingly. On the right hand side, if I select this marker and this marker, this essentially creates a bone between point 1 and point 2 and point 2 and point 3. The final thing we need to do is label this one up. So again, I'll label that as kick, and we will save that on the desktop. Now it's important to note that once you've set up a frame template, you don't have to do that again. So as long as you save that in a safe location, you can use that time and time again. Next thing we need to do is head back to the digitisation menu, and this time we need to calibrate the video file. So if you go to video file calibration and line in any direction, click OK. We can use this little zoom tool to our advantage, but what we need to do is click on one end of the meter rule, drag down and release at the other end. We then accept the distance on the left hand side as 1 meter, and then we accept the frames per second recording rate. Okay, so we're now ready to automatically digitize. So again, go to the digitisation menu and down to automatic digitization of a new trace. Click OK. And here we need to open up our file. We then go to set markers. What we need to do now is scroll to the first frame that we want to automatically track. So we generally find where the movement is initiated, and then just go back a couple of frames. So we click first frame there, and then we just need to scroll through the movement and select the frame that corresponds to the end of the movement. So I'm going to go around there and click OK. So the video is now condensing and preparing for automatic tracking. So if we click now OK, and with the automatic tracking, we just need to identify the markers once. Unlike the manual digitization, where we have to click on the markers continuously frame by frame. So we we allocate them in order of the description down on the right hand side. So if I select the hip first of all, click there, move down to the knee and click, and finally the ankle. Then select OK. From here we can start tracking. Prior to that, we can toggle with the speed at which we track. I'm just going to kind of leave it where it was. Okay, so you can see that it's automatically recognized the markers for the majority of the movement, but it started to miss out the ankle here. So when we perform fast movements such as kicking or striking, then occasionally this might occur, and essentially what we need to do is then manually fill in these gaps. So If I click on the ankle here, do our best to judge where it is. You can see now the knee's gone missing as well. So select the knee and then the ankle, and the same again. So the movement's nearly complete. Like I say, this might happen from time to time. And there we go. So we've now finished the automatic tracking. If we click OK, what we can now do is apply a filter. So we're going to apply a Butterworth filter. And with this, we just need to sieve through and click Next, 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 and save the filter values. We can then exit this filtering window. So from here, we can now perform some angular analysis. So if we head to this little pie chart symbol, it will prompt us to open the file that has just been tracked. So we'll do that. We want to perform a single video angular analysis. And here we go. So for this, I generally suggest we split the screen into two so we can see the action being performed and we can also see the live angular analysis at the same time. So at the moment it displays a rather random angle including this vertical axis. So if we use this icon to clear the angle, and what we're going to do is we're just going to track the knee angle at the moment. So if I select hip in column A, knee in column B, and ankle in column C. So we're basically identifying the joint above and below the joint that we want to assess the angular displacement. So if I now drag through the movement, you should start to see a black bar appear on the right hand side. So we could, for example, specify a particular moment in the action and read off the angular output. Equally, we could identify the angular velocity and acceleration down here. Now, if we wanted to export this data for further analysis, if we go to the Save Results tab and then Save Results in an Excel file, again, I'm just going to pop this onto the desktop, minimize these. So this would give us the data for just the knee kinematics. So we'll have the angular output, the angular velocity, and angular acceleration. If we wanted to create a figure that replicated the one we've just seen in the software, then if we select the first cell in the angle data and then Control Shift down, then we'll go Insert, Line, and there we go. So we can obviously manipulate the axes, etc., but we can work with that data to identify key stages of a movement and the associated angular outputs. I hope this video has been useful. Thank you for watching.